Okay, um, this is a fraction, and we're supposed to simplify this fraction. Okay, this is just like every other fraction. To simplify fractions, let's say you have something like 9 over 27. You're actually looking out for common factors. Um, and here we know 3 is a common factor, 9 is also a common factor itself. So you want to use 9 here, 1, you want to use 9 here, 3. Okay, so we want to do something like this here. So we need to get a common factor. And to get common factors for equations like this or expressions like this, we have to factorize. So we'll factorize the numerator and the denominator and then see if there is any common factors and cancel out. All right, so let's start with the numerator. This is 4a squared. This is 49b squared. If you look at 4, it's a perfect square. 49 is a perfect square. We can do 2 power 2. We can do 7 power 2. Okay, let's do 2a all raised to power 2. Okay, then let's subtract and say 7b all raised to power 2. Okay, why did I do that? Because these are perfect squares, I already have a hint that this would be a way to get something like this. Like if you have x squared minus y squared, you know that if you go x minus y and x plus y and you expand, like x times x, you have x squared, x times y, you have plus xy, you have minus y times x, you have minus xy, then you have minus plus minus y squared. And then these and these can go because they subtract out each other. This way you come back here. All right. So I'm foreseeing this. Okay. All right. So you understand where I'm going. Now, let's look at this. This is not like this, but this is like a normal quadratic equation. You know, the normal way we do it, we look for two numbers. If you multiply them, you get a product equal to the product of these and this. So 2a squared times minus 7b squared is minus 14a squared b squared. And then the sum of the products should be 5ab. Okay. Without wasting time, we already know that um, 7 and 2 will do this for us. But plus 7ab minus 2ab will get this job done. If you add these two, you get the sum of roots. If you multiply these two, you get the product of roots. The negative sign will come from here. So let's just apply it. So 2a squared, because this is 2a, I'll start with this. So we've got more factors between them instead of starting with this. Okay, so minus 2ab plus 7ab, then we go ahead with this minus 7b squared. So I replaced plus 5ab with minus 2ab plus 7ab. And of course, minus 2 plus 7 is 5. So we didn't change our question in any way. Okay, let's proceed. Now let's apply this here, this whole thing here. So instead of writing this, we'll just write 2a minus 7b all raised to power 2. Instead of raising to power 2 now, we'll now put it this way. 2a plus 7b. So they were standing aside like this. And then we just use a negative and the positive. I've already proven that that works. So it works. If you expand back, this time this, you get that back. This time this, you get that. The other ones will cancel out each other. So let's go to the denominator. For the denominator, 2a is common in both of these, so we're taking 2a. we need to multiply a to this to get this. So a here. We need to multiply minus b to this to be able to get this. Minus b. We want our brackets to be the same, so we just put a minus b here. And then think of what we should multiply to a to be able to get 7ab. And the answer is 7b. So we just say plus 7b. And it works for this. Perfect. Okay. So one more step. Let's rewrite that. 2a minus 7b. Close that bracket. And then 2a plus 7b. We close. Over. Let's make this into a bracket. 2a plus 7b. We close. We open another one. A minus b. All right. Let's look out. We have factorized the numerator and we have factorized the denominator. We can see that this factor is common to both sides. So we can cancel this and cancel this. And we are left with 2a minus 7b over a minus b. Wow. Easy.